And it says there are many methods to solve a quadratic. Right? We've done 2 of them already. We have done the methods of factoring and the method of graphing. That's what your quiz was on a couple of minutes ago. Okay, so you can solve a quadratic by those 2 methods. However, those 2 methods only work and give you exact answers when you have rational numbers, right? If there was an I, there's no way you can factor and get I. Your calculator won't give you I. So when you're factoring or when the graphing doesn't give you an answer or an exact answer, you can use the quadratic formula to find the solutions. What are some other words for solutions? What? No, yeah. Well, other than answer, what quadratic terms will we use? Roots. What's one that starts with a Z? Zeros. So zeros, roots, x-intercept, solutions. Those are all ways we might ask you for the same thing. So you have your quadratic formula here. I know you've used the quadratic formula before. It will be on everything. You can sing whatever song you know to yourself, but don't expect me to sing to you. I won't. But A, B, and C are the coefficients on your quadratic. So we'll talk about that here as we look at this next problem. So it says, using the quadratic formula above, let's solve x squared minus 3x plus 4. All right, that's the problem on the top of the page that we skipped. We're going to go back to the graph in a second, but we're going to jump right to the quadratic formula here. So when you have this quadratic, you need to identify A, B, and C. I'm sure you remember, but let's make sure we are all on the same page. A is the coefficient on the x term. All right, so what would A be here if I looked at that quadratic? 1. There's a 1 on the x squared. Right, so A is going to be 1. B is the coefficient on x, which here is -3. And C is the constant. Okay, so A, B, C, if you forget what order they go in, alphabetical. Everything in math is always alphabetical. So A, B, C are these 3 coefficients. Now, first thing you do is you put every one of those values into the quadratic formula. Now, it's x equals because you're trying to find x-intercepts. You're going to take the negative. I call that the opposite of b. What is the opposite of your b term? +3. Plus or minus with giant square root. Now, be really careful with this. I want you to put every single a, b, and c into parentheses under the radical here. So when you have b squared, it's going to be -3 in parentheses squared minus 4 times your a, which is 1, times c, which is 4. All over 2 times a, which is 1. Now, some people have the tendency to automatically, now, you are going to grab your calculator, so you can do that, but you are going to find, and I'm going to pull up my calculator here, you are going to type in just what's the radicand. Remember we talked about that word yesterday, the stuff under the radical. Don't type the radical in yet because unlike Algebra 1, you might get imaginary numbers here. And your calculator won't give you that imaginary number. So you need to type just what's under the radical into your calculator. So go ahead and do that for me. We'll get 3 plus or minus the square root of something. Type that in. And tell me what you get under the radical. Negative what? Negative 25?
Negative 7.
Okay, so you should double check what you got.
I got
Negative 7? You did too? Did you type -3 in parentheses?
No.
Ah. Put -3 in parentheses, everything in parentheses. Alright, so you get -7 there. Now, the reason we practice simplifying square roots is because we need to simplify this radical. Okay? How does square root of -7 simplify? What comes out of there? I, right? So the I radical 7, does anyone need to see that? That's square root of -1 times the square root of 7, which is I radical 7. Right? That's a little off to the side work. So your final answer is going to be x equals 3 plus or minus I radical 7 over 2. Now, within that equation or solution I just wrote, how many numbers are there? How many answers do I actually have here? I actually have 2, right? I have 2 answers. I have 3 plus I radical 7 over 2. That's one number. I know it looks like a lot, but it's one number. And I have the solution 3 minus I radical 7 over 2. That's the second number. Now, are those real, or are those rational, irrational, or imaginary? They're imaginary. So could you have factored this original quadratic? No. All right, so no, you could not have factored this because those are not rational roots. Now here's what an imaginary root quadratic looks like. So I'm going to take my calculator here. I'll just do it at the board. You can just watch. This is what we skipped at the top. X squared minus 3x plus 4. When I graph that, what do you notice? Where are the x-intercepts? It doesn't have any. So when you see a quadratic like this, that's a quadratic that has imaginary roots. Right? The roots are somewhere on in the imaginary world. Remember, there's no real roots. That's why it doesn't cross the x-axis. So that's why you have I here. Right? I know it still doesn't tell you what an imaginary number looks like, but at least you can see what a graph would look like that has imaginary roots. Yeah. Yes, I guess so. You waited till a very inopportune time to ask, but let me pause the video so I can. So let's go back. Let's flip our paper over. That's algebra 1. Okay, so big things to remember with the quadratic formula here. Your quadratic must be set equal to 0 in order to use the quadratic formula. Anytime you're solving a quadratic, whether it be by factoring, graphing, quadratic formula, complete the square, which we're going to do on Friday, has to be set equal to 0. The quadratic must also be in what's called standard form. Standard form just means you have to go x squared first, then the x term, then the constant. So the exponents have to be in order, which is the next point. The exponents must be in descending order. All right, so highest exponent first, x squared, then x, then the constant. So let's look at a couple more here, just to make sure we practice that we're typing things in right, and then we'll do a little bit of practice. So we'll start with number 1 here on the examples. I have 3x squared plus 7x equals negative 3. What do I have to make sure is true about this quadratic first? Is that equal to? 0. So to make sure I do that, I have to add 3 to both sides. That will give me 3x squared plus 7x plus 3 equals 0. Now that I have that quadratic, it's in standard form, the exponents are in order, I can go ahead and put this into the quadratic formula. Right, your A is going to be that first coefficient, 3. B is going to be 7, and C is also going to be 3. So I want you to take a second and put everything into the quadratic formula here. So take the opposite of B, so negative 7, plus or minus. And remember, under the radical, everything goes in parentheses. 7 squared minus 4 times 3 times 3. You should at least, I can't talk today, I'm messing up my words. You should at least have everything that looks like that. So we want to look at the radicand. We're going to learn a new word for this tomorrow, but the number that's underneath the radical. That is what you first type into your calculator. So I want you to do that. And tell me, what do you get under the radical there? 13? Yep, that should be right. 49 minus 36 is 13. Do you guys agree or disagree with 13? You agree? All right. Now I have to think. Can I simplify the square root of 13? No. So this is your final answer. This is the exact answer. So that goes on that top line there. The 2x values are negative 7 plus or minus the square root of 13 over 6. There's two numbers in there. We just condensed it into one plus or minus. Now, are those rational or irrational? Irrational. So could you factor this quadratic? No. So the bottom line should say no. We could do rounded solutions. That would be typing it into our calculator. So let's see. Why don't we have these two rows by the window? I want you to find the negative 7 plus radical 13 over 6. And you guys do the minus one over here, these three rows. So negative 7 minus radical 13 over 6. Okay, so to find both those answers, you do plus for one, minus for the other. And we'll see what you guys get. I'll get a weird decimal, it's okay. You can make a fraction to start. You can do it in a couple steps. It doesn't really matter. I'll do the plus one up here. Did you guys by the window get negative 0.565? All right, so negative 5.566. Okay, what about you guys over here by the door? When you did the minus radical 13, what'd you get? So 7, 6, 8. Yeah? Okay. So yeah, those are definitely yucky irrational numbers. It's not factorable. All right, let's see. Let's try. We'll do one more. Do you want to do 2 or 3? 3? Okay. Yeah, let's do 3. This is a good one. I have 2x squared plus 4x minus 1 equals 6x minus 6. What do you have to do first? Put it into standard form. So you're going to need to subtract 6x from both sides. And you're also, you can do it in one step, have to add 6 to the other side. You want to do that for both. And what quadratic do you get? 2x squared minus 2x plus 5. Yep, equals 0. Now that you are set equal to 0, you can go ahead and use the quadratic formula here. So this will be the last one that we do in our notes, because I think once you know the quadratic formula, it's, a little tedious there. So A is 2, B is negative 2, and C is 5. So when you put this in, what's the first number you write down? What's the opposite of B? Make sure you write that right. Positive 2. So it's positive 2, plus or minus. You'll put negative 2 in parentheses before you square it, minus 4 times A times C. And that is all going to go over 2 times 2. So take a moment, once you write that down, and put the radicand into your calculator. So you can tell me what you get under the radical. 36. Okay. Can I simplify the square root of negative 36? Yeah, I can. What is the square root of negative 36? 6i. So this is 2 plus or minus 6i over 4. Now, sometimes, like this case, I can simplify that a little bit more. Okay, what number goes into 2? I mean, we can break it up a couple ways here. I don't really care. There's 2 options. You can either say what number goes into all 3 of those. 2, you could divide them each by 2 and write this as 1 plus or minus 3i over 2. That's fine. Or, so that's one option to simplify that's totally acceptable. The other way you could simplify this is to break this fraction up into 2 fractions. And you could write that as 2 over 4 plus or minus 6i over 4. Does that simplify? Yeah, 1/2 plus or minus 3i over 2. Do you see how those are the same thing? They're just written slightly differently. I don't care which way you do it. I really don't. I don't care if you break that up into 2 fractions like this or leave it as 1, but you will need to simplify the fraction fully. We good there? Now, do we need, I think the second one was getting 2 rational numbers. Do we need to go over that, or do you want to try the homework and then we can go over it tomorrow if you need? I don't care. Try the homework. Okay. Now, my suggestion, because the homework is a little bit, there's a lot there. Not going to lie. There's a lot of quadratic formula problems. partly because if you don't do well on the quiz that we're going to do Friday, then you have a little bit of extra practice. So my suggestion for you would be like, maybe do a couple on the front, like 1 or 2 on the front, which is just straight up quadratic formula, and then maybe try 1 or 2 on the back with the multiple choice. All right, the answers are all on the back there. So do number 1 or number 3 maybe, for sure. That would be my suggestion. Because we didn't do one like this on the board, 1 or 3. So you can make sure you can do the rational roots. But otherwise, just pick a couple. I would at least spend the next 5, 8 minutes. You can like pack up a couple minutes doing this. Spend the next until like 12:45 doing this. And then tomorrow we will check the homework and we will go over a couple different things. We're gonna learn something new tomorrow too. See you guys.